Yes. Cube is arranged such that its length, width, and height are along x, y, and z directions. One of its corners is situated at the origin. One of its corners. Length of each side of the cube is 24 centimeters. The components of electric field are x, ex, y, z of its respectively. The flux coming out of the cube at one end will be. So what is given here is this is cube. Okay. It's given that one of its coordinates is situated at the origin. So let us say this is at origin, and there is x-axis. Let us say this is y-axis. Let us say this is z-axis. Okay. So length, width, and we can consider accordingly. Now each side length is equal to 25 centimeters, 24 minus 2 meters. Electric field intensity here, it is electric field of x component of electric field is electric field is acting in this direction. X component at Ex is equal to 400 root 2 Newton per coulomb. If so, the flux coming out of the cube is not total flux or flux entering, only flux coming out of the cube is. So flux will come out of this surface only, right? So flux coming out of this. Question number 367. So flux coming out of the cube is phi is equal to E A cos theta. E here is in x direction, so Ex into A area of this is only this surface is length into length. Length into length is L into L square. Theta is for here for this area will be in this direction along the outward normal. This is A bar, A there. E both are parallel. So you can see theta is 0. So it is equal to Ex into L square into cos raised 1. So you can take this as Ex is how much? 400 root 2. L square is 25 into 10 power minus 2 into 25 10 to the power minus 2 becomes 10 to the power minus 4. So this you can write it as this is 10 power minus 2 10 power 2 10 power minus 4 becomes 10 power minus 2. 4 into 25 becomes 100. This 4 into 100 becomes cancelled with this 10 power minus 2. So this becomes 25 root 2 will be the total flux. Flux unit is E into A. Newton per coulomb into meter square is Newton meter square per coulomb is the unit of electric flux. Okay. So what is that? 25 root 2. Newton meter square per coulomb. 25 root 2. Third one, action 1. Okay.
So what you say is
Area is
AQ.
volume is equal, not area. 6 A square. If it is A square is for one surface, or total surface area is 6. We are asked to find the flux through one surface. flux outward means one end means this end, only this end. So flux through one end means only this end. So this end consists of only one phase. So area of only that phase. Length into breadth of that.
Pressure is 40 by watt pressure outside, inside.
Question number 7. So the question is, surface charge density of a soap bubble of radius r. Have soap bubble of radius small r and surface tension T. Surface tension T. Surface tension. Surface tension T. Surface tension is equal to T. Surface tension is nothing but force per unit length. Okay. Surface tension T. So surface what is that? Surface charge density is sigma. Surface charge density of this is equal to sigma. If P is excess pressure means delta P. Delta P is taken as P, then the value of sigma is how much? The value of sigma in terms of the given options T or
Pressure inside minus pressure outside.
excess pressure. Excess pressure you can call as XP excess. That is delta P of what? You have to understand. So inside pressure minus outside pressure. So if you consider soap bubble, it will have two free surfaces. It will have some thickness, small thickness. You can consider like this. Okay. So to deal with this, let us consider like this. What is it? Half of part of this. So it will consist of this. Okay. So here it will, because it will have some small thickness, I have to consider the thickness also like this. Okay, this what is it? Cross section view of this. So hello. No? One second. Monitor. Class lens. 8:30 ಕಲ್ಲ ಆಯ್ತು. ಇಷ್ಟು ಬಂದಿಲ್ಲ. ಇಷ್ಟು ಬಂದಿಲ್ಲ. ಓಕೆ ಓಕೆ ಓಕೆ. ಹಾಂ ಸರಿ ಹಾಂ ಸರಿ ಓಕೆ. See here? Yeah. So if you consider this, you have to understand that it is in its shape means usually atmospheric pressure will act outside. Atmospheric pressure will act in all these directions, in all the directions. But it is not collapsing. So that means it is there is some inside pressure that will be balancing this. But because of a liquid property, you can say here, if due to this pressure, a force will act on this. That force can be expressed as the force due to this pressure can be expressed as pressure is equal to force by area. From this you can say force is equal to pressure into area. Here the force acting on outside is nothing but P naught into A. So this is having some what you call radius R. Radius R. We can say the force acting on this surface is nothing but on this area. How much area it is there? That much area it will act here also. So you can take it as this force, outside force. You can take it as outside force is F naught is equal to P naught into A. It is equal to P naught into pi R square. Whereas inside pressure, if you take it as Pi, inside due to that inside force, if you take it is Pi into A. Area will be same area, surface, the area you can say is how much here. On this how much it is acting, that will be acting here and here also. So like that you can cross sectional area you can take. So it is Pi into area will be pi r square only. But if they're equal, so I can say that they'll be actually in equilibrium. But here, in addition to this, not only this, a tensional, what you call surface tension force act along this interface. So here, if you consider this is an imaginary line, along this line, here, 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 everywhere along this line, surface tension force acts on outer surface and inner surface on two circumferences. So you can say that another force which is acting downward direction is the force due to surface tension. Force due to surface tension it is equal to T into on how much length it is acting here is you can say here surface tension is nothing but force per unit length. So force will be equal to that force per unit length into this entire length will give you force. Effective length. Effective length is 2 pi r into 2 because of two surfaces. So you can take this as 4t into pi r. This is the surface tension, force due to surface tension. Is which direction that's in downward direction. Force due to surface tension. So now you can say in downward direction, force due to this atmospheric pressure is there. This pressure is acting in our downward direction. Upward direction, pressure due to inside force due to inside pressure is acting. This is force due to inside pressure. But in addition to this, here if we have given a charge of what is that? It is having a charge density of sigma means it is having some charge. Due to that, now upward force or outward force will act. That force due to what do you call it? You can also call it as an electrostatic force. Electrostatic force can be expressed as here is equal to again here a pressure will act due to this. So the pressure times area, pressure due to electrostatic force into area. So here you should remember that what is electrostatic pressure here? Pressure is nothing but you can say already if you consider this due to a charge distribution, pressure is equal to force by area. Force in an electric field region can be taken as Q into E by area. But electrostatic field due to surface charge distribution can be taken as Q into sigma by epsilon naught. Sigma by so due to surface to epsilon naught by area. This sigma Q in terms of surface charge density can be taken as sigma A, right, into sigma by 2 epsilon naught into A cancel, sigma and sigma becomes a sigma square, P can be taken as a sigma square by epsilon naught is pressure, but here force equal to pressure into area, so again you can write this as area of this, you have to take it as pi r square for this what do you call for this surface. So you can take this as this pressure is sigma square by 2 epsilon naught into pi r square. It is acting in upward direction due to the charge, electrostatic force. So you can say overall the force due to inside pressure and electrostatic force, two forces are acting in upward direction. These two forces are acting in downward direction. So as the subbubble is in equilibrium, you can say downward forces force due to atmospheric pressure plus force due to surface tension is balancing by force due to inside pressure plus force due to electrostatic pressure. They are balancing. So here this is nothing but how much? F naught here P naught into pi r square.
Force in outside tension. Force in inside electrostatic.
Yes. So this is atmospheric pressure. Outside means atmospheric pressure. And so PA. So FA, P naught are atmospheric pressure. So FA is PA into pi r square plus due to the surface tension is 4T into pi r is equal to not 4 into pi r is equal to inside pressure inside forces due to inside pressure into pi r square. This is sigma square by 2 epsilon naught into pi r square. Here in all expressions if you see pi is common, pi you can remove, and here r square, here r square is there, everywhere r square is there except here. So if you remove this r squares, you will get here one r goes here, one r comes in denominator. So if you divide it as R by R, R square will go off, then R will come here. Okay, like if you multiply R by R, right? Then you can write it as excess pressure is nothing but Pi difference Pi. So if you bring it here, you can say only PA will be here. PA difference Pi is excess pressure. Bring it here, then you can write this is equal to. Or you can say excess pressure will be inside will be like more. I can say Pi minus atmospheric pressure. Bring it here, then you send this that side, then it becomes 4T by R minus sigma square by 2 epsilon naught. The other terms got cancelled. Now this is excess pressure, this is given as P. P is equal to 4 T by R minus sigma square by 2 epsilon naught. But we want sigma. So let us bring this here and we can write a sigma square by 2 epsilon naught is equal to 4 T by R minus P. So from this sigma is equal to 2 epsilon naught into 4 T by R minus P. Right? Whole power half. Whole power half. This will be sigma 2 epsilon naught into 4T by R minus P. Okay? That is how we have to work it. So, electric field components of electric field shown in figure are Ex equal to alpha x power half, Ey is equal to 0, Ez is equal to 0, where alpha is 5 Newton per coulomb. So 5 into x power half, or 5 root x. Calculate flux phi through the tube. So here, it is given that this is x-axis, this is y-axis, this is z-axis. So here, it is given that there is a cube, so which is lying at a distance of from here A, at the A distance it is lying, whose side length is A again. Okay, all are equal. So that if electric or y and z direction no electric field, but in x direction electric field is given as alpha into root x. And alpha is 5, so 5 root x is alpha, Ex. Then you're asked to find what is flux through the tube. Flux through the tube. So here, as it is a function of x, it is not uniform. If x changes, flux changes. So here, at this point, distance changes, flux, electric field changes. As phi is equal to Ea cos theta, as E changes, as area will fix, so E changes, flux changes. So here, inward flux, this is outward flux. At this position, x is A. So phi 1, let us say, phi 1 is inward flux, or phi I is equal to Ei into A will be constant cos theta. So here area vector will be in this direction, electric field will be in this direction, theta will be 180. So area is A square, but electric field is 5 root x is 5 root A. So it is equal to 5 root A into A square into cos 180. Cos 180. What is cos 180 value? Minus 1. Right? So but it is A, root A can be written as A power half, or A into A square becomes A power 3 by 2. So it is inward flux is equal to 5 into A power 3 by 2 into minus 1 is minus 5 into A power this. So this is what. So outward flux is here. So the distance of this side is this is A plus A is 2A. So electric field at here distance is 2A. X is equal to 2A. A plus A. At this point, electric field here at this what do you call? At this point will be, let us say this is P, this is Q. At Q will be 5 root x. X is 2a, so 5 into root 2a. So it is a 5 root 2a into area of this is a square, root is for entire thing, a square into cos. Here area vector will be in this direction, electric field vector is also in the same direction, so angle between them is 0, cos 0 is 1. So you can write it as plus 5 into 2a power half
3 by 2.
into a power half. So you can write it as is equal to 5 root 2 into a power 3 by 2.
Yes, sir.
Sorry, a power half into a power half. A square, right?
Right.
So a power 3 by 2 plus. So it is 5 root 2 into a power 3 by 5 into a minus 5 root a power 3 by 2. Then plus 5 root 2 a power 3 by 2 is outward flux. Is outward flux. So total flux is equal to outward flux positive, inward flux negative. So outward flux minus inward flux is equal to 5 root 2 into a power 3 by 2 minus inward flux is 5 into a power 3 by 2. 5 into a power 3 by 2 is common. 3 by 2 is common. So it is root 2 minus 1. So root 2 minus 1 into 5 into area is given as flux through the cube. Huh?
Sir, inverse minus 5. Plus
Minus
formula
5 naught minus 5i. So that will done. By taking this into consideration, we have taken this. So it is not minus of minus.
Okay.
So you will get what is this? 5 into a power 5 by 2 or 3 by 2. So net flux is this plus this.
Yes, sir.
The one is positive, another is negative. Right? Yes, a power 1 by 2 plus 2 is how much? A power 2 plus 1 by 2, 3 by 2 only, right?
Yes, sir.
A power 3 by 2.
Negative 5.
So it is minus. Why they have taken 5 by 2 here? A square or a by 2. A by 3 by 2 only it is. Right? The flux through the cube and the charge within the cube. Assume A equal to 1. They have taken A equal to 1. Equal to 1. So this is the total flux. If A is equal to 1, then flux is equal to 5A. 5 into 1 is 5. 5 into root 2 minus 1. That's it. Newton, meter square per coulomb. 5 into root 2 minus 1. 5 into root 2 minus 1. Here, you can, if we substitute this, is equal to 5 into root 2 is 1.414 minus 1. Is equal to 5 into 0.414. Approximately 2. 2. Approximately 2. That will be the total flux. Okay? 2 Newton meter square per coulomb. Units. Say units. So similarly, the charge within the cube.
The Q is equal to total flux.
So this is the net flux. You know, flux by Gauss law. 1 by epsilon times the charge enclosed. So charge enclosed is equal to this is net flux.
Flux into
Net flux into epsilon naught to give the charge enclosed. Okay.
Thanks.